So what I put together is a little show. It's a whole bunch of slides. I was trying to call them last night going, oh gosh, but I've got to leave that in. What I'm trying to do is get through site inventory, which is kind of a big topic on its own, but also throw in some plants, and also talk quite a bit about soil, because everyone wants to hear more about soil science, soil ecology, that sort of thing. But also look at it a little more holistically with the idea that along with site analysis, in order to get a design inspiration and figure out what to do, you need to know the program, which means identifying what the users are going to do with the site, and then put that all together and also have an idea of opportunities. In other words, some of those concepts that some of those talks we're going to talk about in mind, so that when you're walking through, you have an idea of what, things will pop up as inspiration. And I give this talk to more professionals, and so I'm going to try and gear it more towards, I'm wondering, how many people here are going to do this for other people or do this professionally? All right, so we got you. Good. All right, so moving on. It's all about relationships. And you're here, so you're already building on that and learning from various different organizations and associations. I wanted to point out a few of them. Are there any master gardeners here? Yeah. Is anyone a bay-friendly gardener? All right. Or maybe APLD or ASLA? Yeah, fantastic. So we're well on our way here, but these are just organizations that are filled with great people and lots of information, really good resources. So, and with those relationships, of course, we want to remember that we're all part of the web, right? I like to get a little bit spiritual about this thing when possible, and knowing that we're all stardust, as Carl Sagan said, and web. We talk about the soil food web and how everything is interrelated in the landscape, and we are a part of that. So that web thinking, again, stressing that program development, site inventory, and concept design is generally kind of done all at once as you're walking around the site. It's hard to pull it out, and sometimes you can say, no, I'm going to do my site inventory, and then I'm going to take my program and then put it together. The best designs usually happen when you're sitting there in the garden. You've got probably having a discourse with the user of the site, and you're thinking and getting ideas and starting to sketch stuff down. That's when the magic happens. And trying to just do one and then the other sometimes falls short. So some overriding principles that I think are important to keep in mind. Of course, land stewardship. That's what we're all trying to do, and I think property owners, for the most part, want to be good land stewards. They just generally need a little bit more input and how-to. Balancing the client program with the genus loci. So genus loci is the spirit of the place, and that is really what you're trying to get a hold of as you walk the site and experience it. What is calling out to you in terms of the history of the space or the geography, the local habitat, that sort of thing. But that might be in opposition to the use and how the owner wants to use the space. So trying to put those two together is always a tough one. Form follows function. Obviously, that's a good way, as I'll show you how to come up with forms. Many times, you look at a blank slate of a yard and you wonder, okay, where do we start? Well, putting down the basic functions of that site gives you the impetus and a way to start with a design. And then, of course, promoting diversity and being fun and creative. Part of land stewardship is understanding some basic principles, and since we've already got bay-friendly landscapers here, I'm just going to go through this briefly, but the Bay-Friendly Landscape Coalition was put together to help reduce waste from the landfill, and then pollution prevention got added in there, and conservation. But all these things put together really helps us landscape with a good land stewardship in mind, doing the right thing for the planet. And a lot of these concepts are actually very useful in best management practices in terms of landscapes, and they can inspire ideas when you're on the site. Ooh, there's a misspelling. It's been Tim.
That's all right.
So, yeah, I mean, the more time you can spend on that site throughout the seasons, the better off you're going to be in terms of getting that site inventory. The more time you can spend with the site users, that's going to be really key. And being open, recording your first impressions. You know, many times you can walk through the site and get all these ideas, and then just wind up realizing that that first aha that you had walking in there was the right one. Ask open-ended questions, thinking about the program now, because many times I think the site part is easier. Don't leave without an idea or concept. I know sometimes you'll sit there and you're at the drafting table or at your computer and going, oh, I got to go back to get some inspiration. So I really have learned you got to just stick around, keep wandering around, thinking about things, and identifying opportunities and constraints. You might even take a pad of paper and just draw a line. What are the cool things we could do here? What are the things that we've got to deal with? Constraints might be board views. It might be well, any number of things. Maybe the soil, maybe the drainage issue. But then you might be able to take a constraint and turn it into an opportunity. In fact, that's usually how good designs come about. So here, the first time I gave this talk was in Ross Valley. And one of the first things you want to think about in doing a site inventory is water, of course, and watershed thinking. So where is the watershed? Where is the water coming from? And many times it's very beneficial to go through the exercise of just being on site and picturing, yourself as a little water droplet and going up, okay, where is this coming from? The whole ridge line, where's the water going? And follow it through, think about roof lines. The roof is a watershed. It's going to come down in all those downspouts. Where is it going to go? Where does it pool? And then leaving the site, what creek or stream or river does it go into? It's just a great way to think about how to do that. And then the next thing is plant communities. Lots of people will say, well, what kind of plants to use? If you can get the watershed idea figured out, and then along that use the plant communities that are nearby as inspiration, you've got half the design done already. It's just a real basic program, really, in terms of coming up with stuff. Use the internet. It took me about 10 minutes to go online and find a few little maps. The San Carlos General Plan has a whole list of endangered species and the different plant communities and habitats. The watershed maps are all there. It's pretty easy now just to click here and there and find just a wealth of information about a site. If you do that before you go out on the site, you're much better prepared to get those inspirational moments. So again, balancing client program with the spirit of the place. The ecology, the geology, the hydrology, the history, and the geography. These are all things to be thinking about as you're walking through the site. So of course ecology, and we can get into succession a little bit, but thinking about the wildlife, the habitat, what's going on there, what used to go on there. Many times you can sit here and know, oh, well, this used to be an orchard, and then before then there was a lumber mill over here. And if you can go back and figure out how people used to use the space, that can give you some really cool ideas as to how you might integrate that into your design. Of course, the geology is going to impact the soils to a large extent. Hydrology is going back to that watershed idea. We talked about history. Geography, I like to think about trying to accentuate geography, and we'll get into that, but it's a really good way to build diversity on a small site. And maybe I'll get into it just now, and then we can review it in a minute. But a good way to think about it is if you had downspouts, say, or water coming onto the site, you could actually figure out where those are going and establish a riparian zone, or essentially a creek corridor in miniature on that site. And then you might think about mounding up and accentuating that geography a little bit so that you've got areas where you could put in a chaparral area. You might want to sneak in a little coastal scrub area in some spot, or perhaps a mixed evergreen forest as a screen for that neighbor's house you don't want to look at. And by using plant communities and geography, you can, I go back, if you can input more geography and accentuate that, you can actually squeeze in more plant communities. And then when those rub up against each other, you've got more diversity, more interest, it becomes a more exciting landscape. More to balance. Looking at the difference between urban and wild, defensible space and fuel load. That's a big one. I remember being at a Master Gardener training where the two speakers of the day, one of them was a habitat person, the other one was a fire prevention person. And you know, that you go, well, you want to reduce the fuel load and the fire ladder and remove all that dead stuff. And the next person said, well, no, you want to keep all that dead stuff. And they were looking at each other like, what? Sterile, sanitary versus homeostasis in terms of creating, again, diversity of habitat so that things can reach an equilibrium there. Exotics and natives. Of course, we're promoting natives, but you know, many times clients will come up with the 5 plants they really want, and none of them are native. So how do you integrate those into the design? And then, of course, you know, do you want pets or maybe small birds and animals? So a lot to consider. Deer can be a big one, but if you want to put in a vegetable garden, maybe not. You might have to incorporate a pretty good sized fence. So how will the space be used? What's the lifestyle of the user? And what elements support the passions of the user? The idea is to get people out there in the yard, integrated, touching nature, having experiences. So how do you maximize that? So I like to look at this in 2 different things. With the site inventory, they say, oh, what am I going to do? We'll take a hike. It's the other one. So if you have open space, you know, pathways, different things, you can get an idea of probably what used to be on that site in terms of the ecology and the plant communities, and try and bring that back. Thinking about circulation is a big one. Circulation, I think, is the key to forms. Many times if you get the drainage drawn out on a base plan, and then you get the circulation, whether it's vehicular or pedestrian, how people walk and use the space, even the way pets race across the land, you can start to see form generation. And that many times will give you the blueprint of a landscape that will work. With the client analysis now, or you know, if this is your own space, you really got to think about what the style is, and the time available, and the budget. I can't tell you how many times I've listened to people say, oh, you know, we want composting, we want a greenhouse, we want roses, we want vegetable gardens, we want, you know, and you listen to all that stuff, and wow, this is really cool. And then you realize that they've got maybe about an hour a week to put into the garden, and you think, you know, that's just not going to work. You can't do all that. And so maybe toning down or advising people not to get so excited about such high-intensity garden elements. So, back in 1896, Louis Sullivan, a famous designer, came up with this form follows function. It's a really cool quote. It is the pervading law of all things organic and inorganic, of all things physical and metaphysical, of all things human and all things superhuman, of all true manifestations of the head, of the heart, and of the soul, that life recognizable in its expression, that form ever follows function. This is the law. And it's true to this day. His assistant was Frank Lloyd Wright, and we can all see how he went further with those ideas. And it really makes sense to really think, how is this landscape going to be used? We talked about accentuating geography and how that can get more plant communities together. Incorporating a riparian area, I think, is key if you can do it. Even if it's a little dry creek bed that only gets a little bit of water here and there and helps infiltrate that water, it's a great starting off point. Using mounds. You know, lots of people will say, oh, well, natives really need fast draining soil and you got to mound them up. Well, yeah, but you know, we've got natives that live in creeks and they like to be wet and moist and live in heavy clay. We've got natives that live in the coastal area in the marshes that like salt. So there's all kinds of different natives. Maximizing ecotones. So an ecotone is where you get two ecologies rubbing up against each other. And plant communities, along with their respective ecologies, rubbing up against each other is where you get big diversity. A good example of that would be Monterey Bay, where you've got the northern kelp forest, and kelp you can think of kind of like a redwood tree or an oak tree and all the whole ecology that it represents. And then you've got the southern kelp forest and its whole ecology. And where they overlap, you know, the diversity just goes through the roof. And so if you can take that woodland or that chaparral area with the meadow and the riparian area and get those rubbing up each other, you're going to have a lot of habitat opportunities and a really exciting garden. Planting edibles, yeah. Tubulars, I came up with that one. Tubulars are great. Plants with tubular corollas, all right? So these are things that the hummingbirds will love. Flowers, tubular flowers, I should say. These are the long, and composites. Composites would be things like daisies, the typical, what it is for nectar, right? If you've got a whole bunch of those little flowers in a small spot, it's great for plants or for insects that need the nectar and the pollen. Habitat, interaction, anyway. So let's talk a little bit about function and how to get folks out into and integrated and using the space. Again, right, the budget and the experience level and the maintenance commitment is big. If you look at the client and you think, oh wow, they're not going to do it, you don't want to put those high maintenance elements into the garden or it will be a disaster. So, I like to say that one's garden is at once an extension of their spirit and both a place and a conduit for their development and expression. It's kind of a spiritual way of thinking about how the garden is an extension of the people that use it, and yet also part of the historical and geological history of that space. Oh no, we're not going to go through that. I'm going to... sorry about that. This is from an old thing. So modern garden function, right? There's so many things. We think, oh, we just want to have some room outside. It used to be that gardens were for sanctuary. Gardens were for privacy. Gardens were to keep, you know, the bad guys out and make a safe space so that we can survive. But now we're entertaining. We've got exercise, sporting areas, dining, cooking, providing cut flowers, salads, fruits, berries, seasonal vegetables, right? Seasonal color, storage. You always think about where you're going to put the store. Where's the shed going? You know, you don't want to come into someone's yard and take out their whole utility area and don't leave them with a space to put stuff. Thinking about promoting birds, butterflies, beneficial insects, maintaining a healthy aquifer and a good habitat corridor. Okay. What I mean by that, let's say you've got an open space over here and say a big park over here. Let's say you've got maybe a creek, a riparian corridor here. That's how the habitat gets around. And what you want to think about is that each one of these little yards is like a stepping stone. And that's how the habitat can get from one big open space to the next. So, of course, in habitat, and again, these are just some design concepts that you want to have in mind going into a site where you can say, well, okay, where can I put a food element? How about a water element? Is the client open to a water feature? Maybe they want a pondless water feature because they've got little kids. Maybe it's just a little gurgling thing, but something so that you can have some water for the habitat. Cover, right? You don't want to have it all sterile and open up. Protection, and of course, we're not going to use pesticides there. So, let's jump ahead. Ultimately, right, it's a direct result through a self or client analysis and a detailed site analysis. And the site analysis is really the easy part. Getting a hold of you know, like I was saying, a good garden designer here is either a good psychoanalyst and sometimes a good marriage counselor. Because you go in there and you're hearing two totally different things. And you got to go, well, okay, guys, let's try and put this together in something that the whole family can use and be happy about. So, how to get there? I just threw out some questions here that are asked. You can ask. You know, I like, well, what are some of your favorite fragrances, colors? Do you have a favorite form or texture? Yeah, do you want a pond? Why do you have a lawn? Is it really being used? You might say, oh yeah, well the grandkids come over, or something like that. What do you think of when you hear the word habitat? Some people think raccoons and rats. And you go, oh, all right, well, you know, maybe we won't go there. So how do you spend your time? You know, do you like to create? Are you sharing? Do you want to relax in the garden? You know, how is that space going to be used? And if you can get all that information and apply it to what's there, what used to be there, and what inspiration you have, you're going to come up with a really nice design. Oh, yeah. So what's there? The old garden bones. And thinking about opportunities. So you can throw some of these out at them as ideas. You know, swings, pools, rain gardens, butterflies, tree forts, chickens, pigs. Maybe they want fruit trees, subtropicals. Maybe they want roses. Outdoor fireplaces. I've done a lot of gardens where the outdoor fireplaces, the key is front and center. So then, of course, we get to site analysis. Hopefully we've got a good idea of who the users of the space are, what they like to do, and inspiration. Site inventory tools. I love to head out, I'm just going to jump over here. Having a clipboard with some graph paper is fantastic. If you can use 1/8" graph paper and work in 1/8 scale, that's usually pretty good for most residential sites. I also like to have one of these cool little pens where you've got different colors. It really helps because you can put different layers down there all on the same page, and it makes it a lot easier to read when you get home. Having a tape measure, right, something like this is great. It's got a little hook on the end so you can put that on the corner of a building or on a fence, pull it out and start measuring where the existing trees are or the hardscape is, all that stuff, and even along the house. Having another smaller one on your belt is very helpful. If you're going to have a soil probe, one of these guys, this is great. Just to be able to, you know, a shovel will work, but this is pretty cool to be able to go in there and figure out what kind of soils you've got, how deep it is, figure out how much organic matter is there, whether it's aerobic or not. Sharpie marker and a Ziploc bags are good if you want to do a soil test. It's always nice to be able to dump some soil. About 2 cups is what you need as a representative sample. And then mark where you got it and what the site is so that when you look and there's 4 of them in your trunk, you go, oh shoot. Digital camera, sometimes a pressure gauge if you want to get on a hose bib and figure out what the water pressure is, and knowing that, okay, with this landscape is going to come irrigation someday. And then this is kind of fun. You know, the smartphones now have compasses on them. And it's pretty easy just to go and look at it and go, okay, and you draw on your little plan, that way is north. And then you got it set. When possible, if you can show up with a site plan or a survey map, or what I like to do these days is a Google aerial image. You go on Google Maps or Google Earth, you find the site, you blow it up as big as you can on your screen, you take a screen capture and you print it out. And if you can, down in the little corner of that screen capture, you get the scale, right? And then you'll say, okay, so that's 50 feet, there's that tree, and it's wonderful. You can really orient yourselves, and it's nice to be able to take notes right on that. A county plot map, historical water data, and seasonal water information.
What does ETO stand for?
Oh, okay. Well, ET phones home. ET is evapotranspiration. So if you take what evaporates from the surface, and transpiration is how plants release water through the stomata on their leaves. So you add those two things together and you get evapotranspiration. It's how much water leaves the site. And you can get an ET curve that shows how that changes throughout a season. The other end of that is rainfall. Water in, water out for a particular site. And I'll show you a chart that will help explain that. So what we want to do is we want to find out a little bit about soil and what texture is it. Is it sand, silt, or clay, or maybe a mixture? We call it loam. We want to look at wind and sun and think about microclimates, seasonal and daily changes. You know, generally you can look at a site and go, okay, well the north side is going to be cooler, but you know, in this situation, I know we get probably an afternoon wind, I'm guessing, and as that hits the various buildings, it might get really windy through some little wind tunnel, or there might be a parking lot nearby that would have a heat island effect. And so you'd have these microclimates. There might be a south-facing wall that gets really hot. And if you know that, you can think, oh, hot south-facing wall. I can put this, you know, maybe more tender plant there so it won't freeze. And they can inspire plant choices in these different little areas. Drainage is key. I mean, that comes first. You want to know where the water's coming from and where it's going. And if you can use that information as part of your design development, even better. Adjacencies and existing structures and paths, screening, right? I mean, when it's also nice to get in the house, not just walk around the yard, but actually, you know, stand at the kitchen sink, go into the living room, figure out where the users of the space, even inside the house, what do they see? And you can go, oh, look, there's a street light on a telephone pole. Well, maybe we can put something tall and screen that out eventually. Or maybe there's a neighbor's window that's looking down in. They've got the, you know, the fishbowl effect, so to speak. So there's all those ideas that can give you an idea of where you need screening. And circulation and flow. So I'm going to take you on a whirlwind soils class. Kind of fun. And so, have you all heard of the soil food web? There's a wonderful scientist named Dr. Elaine Ingham. If you haven't heard of her, you ought to look it up. Look her up. She's just fantastic. She just got appointed as the Rodale's head scientist. And she is really fun to listen to her talk if you ever get that opportunity. She is a soil biologist, and soil biology is really new. When I was in Cal Poly, which wasn't too long ago, and went to all the soil classes, they taught us the nitrogen, phosphorus, potassium, and here's how you do it, and you know, ammonium nitrate, superphosphates, that's it. We did not talk about bacteria and nematodes. And yet this is totally changing the way we think about soil. We've got these microarthropods in the top layer, the mulch layer, that decompose all the leaves and make that material available to the fungus and the protozoa down in the soil as food. And it all starts with organic matter. It's really amazing. And I mean, I talk about spiritual landscaping, and this is where it's at. So the rhizosphere is that area, just like the biosphere on the Earth is that thin layer of life covering our planet. The rhizosphere is that thin layer of life covering roots of plants, and especially right up around where the root hairs are. So this area right in here, if this is the tip of a root, this is called the rhizosphere, and that's where all the magic happens. We've got in there bacteria, protozoa, nematodes, mycorrhizal fungi. You all heard about mycorrhizal fungi?
Yep.
Yeah, pretty cool. And what they do is they do nutrient cycling, disease suppression, and they essentially mineralize soil and transport stuff to the plants. And the really magical thing about it is that the plants are in charge of all this. So just to give you an idea of the huge numbers we're talking about and the diversity, think about a gram, all right? About a teaspoon of soil or something equal to a couple of paper clips. That's a gram. And in a gram, you can have up to 3 billion bacteria. That's a big number. 75,000 species. That's huge diversity. Protozoa can be divided up between amoebas and ciliates and flagellates, but again, you know, 1 million of them. And then you've got the nematodes. Nematodes are like little round, blind worms. Very, very small worms. And then miles of fungal hyphae. Up to 1 million fungal cells and 25,000 species in that gram of soil. And it's just amazing. And these guys are all interacting, eating each other in this web of life within the soil. And the end result is mineralization and nutrition for plants. So plants actually are the conductors. And what they do is they pump out materials to help control these things. They're busy photosynthesizing and making what are called photosynthates, which would be sugars, carbohydrates, proteins, amino acids, hormones. This is, I know you can't read that, but I want to just give you an idea of the number of different materials that plants exude. And they say that between 40 and 45% of the tree's energy go into photosynthates that are pumped out through the roots in exchange for what is, the ecology brings them. Here's a quick picture of what bacteria looks on fungal hyphae. So this is good fungus. You know, that's that whole paradigm shift as people say, oh, fungus and bacteria, kill it. No, 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 no. We want all these guys. There's a very, very small portion of these organisms that are pathogenic and bad for plants. So, fungi. That is a root coated with fungus, and these are not root hairs. Those are mycorrhizal fungi strands. They're actually heading out into the soil, and they're mineralizing and bringing nutrients back to the plant in exchange for those sugars and carbohydrates and proteins. Look at this little conifer seedling. Its roots extend to right about here. Now look at that. Do you think maybe that plant has more nutrients and more water absorbing capability because of its symbiotic relationship with that fungi? Yeah, it's hundreds of times better. So they, I don't want to get too into this because it's a little involved, but just to say that the endomycorrhizal fungi get its name because they actually put their spores inside the roots, and they germinate and they come out and they go out and they get, this one in particular picks up phosphates. Ectomycorrhizal fungi is primarily on conifers and large deciduous trees, such as perhaps like a walnut. This is, if you ever dug up walnut roots, they kind of look like that. And those are not root hairs, those are fungal hyphae, ectomycorrhizal. And those the fungi are 1,000 times as absorptive as root hairs. So it's just huge difference in terms of the absorptive capability and being able to get water and nutrients. Now, if that weren't amazing, this is just a side note here, but you talk about carbon sequestration and how we can really be a part of the solution. Just as plants have exudates in their roots, the endomycorrhizal has an exudate, and it's a heavily made up out of carbon. It's very strong. And whereas the mycorrhizal fungi only live for like 2 or 3 weeks and then decompose, their sheathing that makes them strong and able to go across these large soil pore space gaps and transmit nutrients back. They're acting kind of like a pipe, and that strong covering is made up of what's called glomalin. And Sarah Wright was the researcher who found this stuff. And they think that 1/3 of the world's stored soil carbon is in glomalin, much more carbon than in humic acids, which is pretty amazing. So you can look that up. I want to give you an idea of succession. Everyone knows that plants have succession. It starts out as bare ground, rock, bedrock, parent material. The weather hits it, you start to get weathering and sand. Pretty soon you get weeds, right? And those early adaptive plants go in with lots of fast growth and tons of seed production. And then they grow and die, grow and die, grow and die. And pretty soon you start to build up organic matter in the soil. Those early soils are good. They support bacteria, and they usually have a high pH. As these are called trophic levels, and as the organic matter builds up in the soil, it makes sense that pretty soon you're going to have enough organic matter there to support saprophytic fungus that decomposes that organic matter. And then as you move further up into the old growth forests, your organic matter goes way up. You go from a bacterially dominant soil to a fungally dominant soil, and your pH goes from a high pH to a low pH. And the reason this is all important and has anything to do with gardening is that what I see happening lots is that people will take a trophic level, say here, where it's primarily grasses and weeds and maybe a perennial or two, and they stick in woodland plants. You know, we're going to stick in, I want camellias and hydrangeas, and you wonder why they're stressed. Well, they're co-evolved with fungi and this whole ecology with the soil that's up here, that's not in this area. So, thinking about when you're on a site, what trophic level is it? Where is it on the succession? And what plants really do well there? Are you dealing with a woodland garden? Are you dealing with a grassland garden? What's the pH of that soil? The acidity of the soil can give you a really good indication. So can the organic matter. Being able to figure out, is it rich, filled with organic matter, or is it more sandy, gravelly soil? Now, if the client has a lot of money, you can push succession very quickly. I mean, in nature, that might happen in 40,000 years, 50,000 years. You could do that in a weekend with a bunch of dump trucks and yards and yards of compost. You can really do it if what they want is that kind of plant material. But it's interesting to think about. Or, you can respect what's really there and say, you know what? We're going to put in chaparral plants because that's what's here. You're not ready for those woodland plants yet. All right, so texture has everything to do with size. And we've got sand, silt, and clay. Clay is really, really small, 0.002 millimeters. You can't see it. It's so small that it has an electrical charge, though, and it has a huge surface area. If you ever get a soils report back, they'll tell you about CEC, or cation exchange capacity. And you know, opposites attract. So if you've got a negatively charged clay particle, it holds on to all of the cations, or the nutrients. So you've got, well, you know, calcium and potassium, magnesium, all the essential plant nutrients are held on as cations. And then you can see the huge surface area. So sand, in 1 gram, again, those 2 paper clips worth, 45 square centimeters. Whereas the same gram of clay, you're looking at something that's almost the size of a football field. Enormous. Another way to look at it, a pound of sand has 0.0005 acres of surface area, whereas a pound of clay has 90 acres of surface area. If you hold a pound of clay in your hand, that's a lot of surface area. So what we want to do is we want to increase soil aggregation, or look and see, as you're doing your site inventory, how is the soil aggregated? Is it compacted, or do you have good soil structure? Because whereas sand, silt, and clay, and how much of it determines what textural class you've got, how it's glued together into aggregates determines the soil structure. And ideally, you'd have about half solids and about half soil pore space. As you increase soil aggregation, you increase the pore space. So you can see here's an example of soil with good texture. You squish it and compact it, that's the same material. They have the same texture, but a totally different, that has no structure. Okay? These are soil aggregates, and you can see the sand, the silt, and the clay is in there, but it's probably too small even in that picture to be seen. Why do we want to know this? I want to try and explain quickly water holding capacity. So a heavy clay soil is going to have a very slow infiltration rate, so you're going to have a lot of runoff. A sandy soil, the water's going to infiltrate really quickly, but then it drains quickly. If you can build up what's called a loam, right? Loam is something right in the middle of the soil triangle. So the loam is equal parts sand, silt, and clay. Then you've got more available water, because clay is small, has smaller little holes, and it holds onto the water tighter. There's a whole bunch of water that the plants really can't get. Increased soil aggregation gives us more soil pore space, which is faster infiltration rates, higher water holding capacity, less erosion, faster recharge of our aquifers, increased aeration, which is better gas exchange. Then you get healthier plants, better ecologies, and then you get less pests and diseases and less fertilizer. It's wonderful stuff to see good soil structure. And it's really easy to take a soil probe or a shovel and say, okay, how are we doing here? Usually the answer, if it's, no, this is compacted dirt, it's dead, what are we going to do? Well, you can take an Om moment, and next time you go to yoga, think about Om. It's organic matter. That's what we add. It's the foundation of the soil. It can turn dirt into soil. When you buy fancy fertilizers, it'll say, oh, it contains humic acid. What does that mean? That is mined humus. When organic matter decomposes, it turns into humic acid, and it's stable. And it sits down there and eventually actually becomes like coal. In fact, right above the coal layer, they have what's called brown coal or brown tar. They scrape that off and mine it and sell it to us gardeners as leonardite. It's a mined humic acid. So, yeah, do we want to wait 40,000 years for that? I also want to point out the problem with anaerobic conditions and why soil porosity is so important in getting oxygen into the soils. If you have less oxygen, you're going to lose nutrients. Ammonia goes out, that's your nitrogen. That's your phosphorus. Here's your sulfur just leaving as gases, and you can smell it. If you dig down and you smell a sulfury smell or an ammonia smell, you know, oh, that's anaerobic. We need to really cultivate this area, get the air in, get the organic matter in. Less than 6 parts per million of oxygen produces 25 parts per million alcohol because of the fungal yeasts in there fermenting. And that'll just dissolve plant tissue. It's bad stuff. And you can recognize it by gray or sometimes black. If you dig up someone's lawn and you see that black layer, that's gone anaerobic. And the roots can't penetrate. Really easy to see black and gray stuff like that. Maybe you're out on an old agricultural area, and for years and years and years they were using a plow, and you've got what's called a plow layer, you know, and that's going to really limit your root depth. So just knowing, well, how is that going to affect the trees and shrubs that I plant? This shows what disking does to the subsoil. This is compacted, pretty low oxygen. This is where the roots are going to be growing. And it just gives you an idea of, is this a compacted site or not? You go into some homeowners associations or condos and you realize that all the good stuff was scraped off. They came in with their D9s and pounded it and scraped it, and they made what's called engineered soil. It's soil that is great for roads and foundations and street lights and that sort of thing. And then the low-bid landscaper came in and did very little tilling, added just the bare minimum of soil, threw the sod on, dug holes barely big enough to fit the pot, and mulched it, and away they go. And then you come along and go, okay, we want a native garden. What are we going to do? You know, and so being able to recognize that, taking the soil probe and going, wow, what's down there? Let's dig a hole. See what if you see roots of the trees coming up and just going along the mulch and into the lawn, that's a pretty good indication that the soil is like concrete there. Or it could have rocks. A good way to look at texture is to try and make a ribbon. So if you get the soil and you make it moist, you make a little ribbon. If you can make a 2-inch ribbon with that without it breaking off, you've got heavy clay. Simple as that. If it's all scratchy in your fingers, you've got sandy soil. Really basic. So you don't need a fancy soil test. If it looks like that, yeah, you got problems. Now, there are native plants that love to grow in this stuff, but not a lot of really nice ones. You know, you're going to be really limited in your plant palette. If you take your soil probe and you see goop and then gray stuff down in the bottom, you can say, oh, that's gone anaerobic. That's a little warning flag comes on. So when you do take samples, you want to make sure you get them in the lower areas or the ridge lines. In other words, on a large property, you might have different parent material. You might have different soils. And if you do want to send them off to get a lab test done, you'd want to get different representative samples. All right. So here is a list of some of the stuff you might consider trying to get when you're actually out there with your tape measure and your clipboard and you're writing this stuff down. House dimensions, right? And that includes all the little windows and doors, hopefully, so that you know when they're sitting in the living room looking out, what are they going to see in the plan? Confirm fence lines, curbs and streets. Don't go by the plot map that you get at the county. Because of the easements, the road is hardly ever is it where the county says it is. It's usually off by at least 4 or 5 feet. Sometimes a lot more than that. Sometimes you'll find that there's a road easement that's 60 feet wide, and the road you're looking at is only 14 feet wide. So big difference there. Hardscape dimensions, all the paths, patios, driveways, that sort of thing. Looking at existing wood structures, right? So the shed, the back fence, the gates, arbors. Think about existing plants. You want the location, the name, the size, the trunk location. I like to draw a big, heavy circle for the trunk and try and make it representative of how big the trunk is, and then draw a circle to represent the canopy, the drip line. Right? So if a big fog were to hit that tree, where would the fog land. And that's really helpful, because many times you'll have a big trunk, say, of an oak tree, but because of the wind, the oak, and where the sun is, the canopy is way over here. And it's great to have that on your plan. You don't want to think, oh, well, there's the oak, and so the trunk's there, and you get all your paths figured out, and then you go and you realize, oh, wow, the trunk's way over there. Didn't catch that. Rough elevations. Now, if you're working on a hillside garden, this is really key, and it's really good to kind of know. What I like to do is either take a tape measure, or you can get good at knowing how tall you are in different parts of you, right? I mean, this is 3 feet right here. This is 4 feet. My nose is 5 feet, and I'm 5.5. So I can look down my nose at a slope and go, okay, that's 5 feet. I can go stand at that spot and look, okay, that's another 5 feet, and mark it on the plan, and then come up to the top of the slope, okay, let's see, 3, that's about 2.5, and come really darn close. So that later, when you're trying to draw in your steps, and you're doing the math, and okay, how many steps do I need? Can I make that work? It's really nice to have at least a close estimate of the elevation change. Views, good and bad. You know, if you get up to the top of a hillside and go, oh my gosh, this is gorgeous, write it down. Downspouts are key. Again, drainage, that should almost be up at the top, along with house dimensions. Is where's the water coming from? And then, of course, the utilities. Where's the existing controller, if there is one? Are there hose bibs out there? Do they work? Where are the valves? Where's all the utilities? You know, existing barbecues, kids' toys, that sort of stuff. So, that's kind of hard to see, but you can see this how the multiple colors work. Whereas I'm going to sketch in the outline of the house, and then in one color, and then I'll go back in another color. I've got a red pen now, and I'm doing dimensions, so I can put the end of the tape on the corner of the house and go back and say, okay, that's this window, that's that door, that's that window, and just write down those dimensions in a different color. And then go out into the landscape with another color, say the green, and start to put down where the existing plants are. And here you can see, like, there's a trunk, there's a couple of trunks, there's a canopy, here's a trunk with a canopy, here's another trunk with a canopy, and indicate what these plants are. This is elevation. So I stood down here and looked up, okay, at the top of this slope, it's about that elevation change. And then to get up here, where I saw this fantastic view, you know, that's where the bench is going. So how high is that? So that later, when I'm going to put steps up into this area, I can see how many steps is it going to take, and how long of a distance is that going to take. So, existing irrigation, existing downspouts, where's the electrical coming from, note views. So, get home and sit down on the little CAD program, and that's the same house. And then up here's the bench site, and I was able to figure out how many steps I needed to get down. There's all the trunks of the oaks, and then it's pretty easy with the circulation of where the paths are, where people are going to walk, to say, all right, well, here's how you get around the side of the house, here's where the, they wanted vegetables, but they got deer like crazy, so it has to be fenced. They wanted a water feature, take advantage of that slope, but it's got to be viewed from inside the house. So where are the windows? Can they see that water feature from all the different vantage points inside the house? Where's the seating area? Wow, there's another huge view out across the valley this way. So maybe we've got, but this is the entry space. So we want to screen here so that they've got a private backyard area, and this still takes advantage of the view, but it's out kind of in the front room, so to speak, of the landscape. So then you got to think, okay, what else do I need to look for? Setbacks are big, especially if you're trying to place like an outdoor kitchen or a hot tub or something like that. Height limits. If you're on a corner lot, the vehicular sight lines are going to determine how high things can be as you get closer to that curb. Easements, vehicle sight lines, yeah, CCNRs, that's a big one. If it's part of a homeowners association or a neighborhood association, call them up. Say, hey, do you have any landscape rules? And they'll go, oh yeah, we do. I'll fax you over the list. And you can go, oh shoot, okay, can't do that. I was at one place where they said, you're not allowed to dig any holes, you're not allowed to have any bird feeders, you're not allowed to have any dogs that are over so many pounds. And it was like, what? Really? So, you'd be surprised. Or I know another homeowner association that says, or neighborhood association says, no redwoods, illegal, you cannot plant a redwood tree. We've had too many lawsuits with, loss of views, can't do it. Design reviews, fire marshal. I know some fire marshals that won't allow you to use shredded bark of any kind. So if you can go onto Google and pick up an aerial photograph that shows where the road, the driveway, and the house is, and then you can go on and find the topo map, and then you can get the county plot map and be able to put the lot line on there and bring that to the site. If someone says, I want to put in a pathway, I want to take advantage of this lower meadow, and there's some great views over here, so what do I do? Being able to do that beforehand is huge. And that way you don't find yourself bushwhacking out here in the bushes with the client all excited about some tree, and you guys go, that's not on your property. Sorry. Right? It's happened. So ET, evapotranspiration, and then rainfall. Just knowing how much water you get and then how hot it gets. Knowing this tells you how cold it gets. This is great. You can go to the new USDA hardiness map, punch in your zip code, and you punch it up, and it'll tell you how cold it's going to get and when and for how long. That's really good information to know when you're talking about subtropical plants with a client. You look it up on, this came from Wikipedia. You just look up the county. And it says here, annual precipitation average 18.77 inches of rainfall for this area. Gusty afternoon winds allowing fog to flow towards San Mateo in the late afternoon through early morning. So that's nice to know. All this great information. So before the design and you're on site, just some more things to think about. We talked about flow, right? That's, you got to think circulation and drainage with that. Elevation for steps, terraces, and slopes. And then hydrozones. Hydrozone is a tricky name for how you put different water needs plants on different valves, essentially, for irrigation. But you can think about it in terms of planting and plant types, and even different plant communities, where your chaparral area is on a different zone than your mixed evergreen forest, so to speak. So flow, yeah, cheap. So since 4000 BC, they've been using the flow concept to design where houses go and where circulation goes and where that rock is supposed to be placed. It's an ancient study, and there's huge texts talking about this, and it all really makes common sense when you get down to it. So you got vehicular flow, pedestrian flow, drainage flow, right? We're looking at screening stuff, destination points, looking at loops. To make an interesting path in the garden, it's really nice if you can have a loop, something that someone can take their morning coffee and stroll around, and then there might be a destination point where they can sit down and enjoy the space. I talked about exaggerating geography in terms of drainage courses and landforms. That really helps set the stage before you even think about plants. Basic design stuff, and I'm kind of racing through here, but go too late here. Good old Tommy Church was talking about unity and function and simplicity. Jens Jensen's, this is cool, curves, the delayed view and the long view. So that's where those old gardens had the big LA, you know, and where you're coming along a path and then all of a sudden you turn and wow, you can see down and there's an accent element down there or a cool plant. So something to think about. Of course, with native gardens, we tend more towards the naturalist garden. I brought this up before, but what we're trying to do now is transition our whole paradigm from drainage systems to infiltration systems. Now, the whole key thing would be that any water that falls on that site should stay on that site, if at all possible. And the best way to do that is by creating these infiltration systems, where you can get water to pool and slow down. There's this saying, slow it, spread it, sink it. And if you've ever heard Brad Lancaster speak, he's a hoot. He is hilarious. Guy from Arizona. But the idea of taking a drainage course and slowing it down, letting it soak into the land, it lots of benefits. And ultimately, it means you have to irrigate less. Or you can store it. You know, rainwater harvesting is a real option. If I took that rainfall of our area, that 18.77, and multiplied it by the 620 gallons of water for every inch of rainfall, we come up with 11,637 gallons of water for every 1,000 square feet of roof you've got. That's a lot of water. And if you're used to looking at your water bill, that equals about 15.5 units, or CCFs. So you can have an idea of, wow, you know, we do get a lot of water here. It just happens all at once, and then it goes away. If we had the storage capacity or got that to soak into our soils, maybe we wouldn't have to irrigate as much. Elevation, views, wonderful stuff, and understanding how to read and create little topo lines. So if you're trying to show a mound in a garden, you can create little lines, and you can determine what the contour interval is going to be. You know, as 1 foot, 2 foot, and you can say, all right, this is going to be a mound, the peak is going to be over here. And that way, whoever's going to build this mound, they can look at your plan and go, oh, yeah, there's where the top goes, there's the bottom, there's where it drains. When you're at the top, you know, I love putting in benches. Even if they never get sat on, they look cool. Here's a couple examples of clients I worked with where we walked over here underneath these oak trees, and he stood there and just went, we looked and he's looking out. He had no idea he could see San Francisco from his yard. Wow. He said, I want, yeah, I want a bench right here. So we built him a little bench site. This client was in Ross, and they, from the top of their site, they could see Phoenix Lake in the watershed. So, okay, let's build it up. Arbor, bench swing, go for it. And they spend a lot of time up there. You know, before it was just, way up the top of the hill somewhere. It became a key element in that design just because we walked up there. And you know, this is really nice up here. I'd like to spend some time up here. Sunlight. Now, sunlight is precious on some sites, and if someone mentions vegetables, you know, okay, where have we got, you know, because everyone wants to grow tomatoes, and you think, well, you got to have a lot of sun to grow tomatoes, like, you know, good 6, 7, 8 hours maybe. So where are the trees? Same thing goes for lawns. If they really have kids and they really have a recreational use for lawns, you know, put them in the sun if you can, so that they're healthy. And you don't have callbacks going, why is my lawn dying? But hillsides also work. If you got a hillside covered with Algerian ivy, but it's in the sun, you can put a vegetable garden there. Or a native garden. Egress and access. It's really nice to have a conversation about, you know, okay, do we need gates? How are we going to get to this space? This walkway or staircase was put in because the kids went down through this area to get to school every day. And there were some really nice landscape areas in the yard, in the lower yard, that were almost inaccessible. The adults would slip and slide, and you know, they're worried about breaking their parts. Up at the top, it's always nice to throw in a gate so you can get out in the case of a fire or something like that. Terracing. Yeah, it's, if you have no level space, you can make it. And retaining walls are expensive, but they do work. There are rules and regulations and all that associated with it. You can do some cut and fill and slopes in between. I wanted to, when we talk about slopes, I want you, if you remember anything about slopes, think 2%. If 2% means everything. When someone says, I want a level patio, go, okay, 2%. Because if you've got a lawn or a rough patio, bricks, flagstone, anything like that, if you don't have 2% grade, you're going to have puddles. And people are going to slip, and it's going to get mossy, and it's not a good scene. 2% is the way to do it. So 2% is 1/4 inch per foot or 1 foot over 50 feet. Just as an example, big flat patio, 2%. Little patio, 2%. Even on steps, 2%. You don't want a puddle back in there. And it's nice just to have this going forward. So when you're on site thinking about patios and steps and thinking, well, can I make it? Because here's the door and there's the slope, and you want to figure out how much grading you have to involve. You might go, that's not going to work because it involves too much soil removal, depending on their budget, of course. So again, with steps, or even if you're doing forms for concrete, it's all 2%. Knowing the difference, the average treads and risers on steps, so that you can figure out how many steps you need to get from point A to point B. Always, so minimum 5-inch risers, right? Never do a single step. That will trip and kill someone. If you got one step, do a bigger slope. Riser variance. When the building inspector comes out, these risers cannot vary more than 1/8 of an inch, or they'll make you do it over. Especially if it's to the the entryway. Landings. It's really nice if you can do stairs in multiples of 3 and then have at least a 3-foot minimum. If you do that, in most municipalities, you can actually get away from having to put in a railing. But once you have 3 or more steps without a 3-foot landing, legally you have to put in a railing. If you have more than a 30-inch drop, then you need a guardrail. A guardrail means you can't fit a 4-inch sphere through it. That represents a baby's head. It's amazing how these things come up. Drainage is also 2%, right? Inside a pipe, not that you're putting in a lot of pipes, but when you think about, okay, if I have to get into, say there's a swale, a drainage swale, and you got to drain the patio into that, you got to have 2%. Otherwise, what will happen is the silt will settle out and your pipe will clog up. So 2% works on top of the ground and below ground.